Hi, and welcome to this breakout session on cloud identity and access management. And today I'm going to focus on how to manage your cloud policies efficiently and at scale. So in this session, I'm breaking it out into 4 pieces. We're going to start with the core concepts of Cloud IAM, what it means and what we do. Secondly, we're going to have a deep dive into a bunch of best practices. How do you actually manage at scale? Third, we have a customer story from Credit Karma coming up on stage, explaining how they manage their cloud resources. And last, we have a super secret, not yet launched feature that you're getting a sneak peek. So take a step back. And what is Cloud IAM? What do we do? We answer the question, who can take what action on which resource? There's other policies in cloud which people sometimes get confused and think that, oh, is this identity? No, it's not. So org policies specifically are which configurations you can have. Another example is quotas, which is how much money can I spend, how much have I spent, where who pays the bill, right, for this resource? So the first, we're doing the deep dive into the core concept of Cloud IAM. Cloud IAM provides a fine-grained access control. And we do that in multiple dimensions. And some things I'm going to talk to you today about is appropriate if you're a garage, you're a startup, or you're just a happy student. Other things are focused on large-scale deployments. So we start with the core concept. Permissions. Everything in IAM is based on IAM permissions. They have a special structure. They start with a service name, followed by the resource type, and then the verb or the action you can take on this resource. Let's take an example, storage.buckets.create. It's obvious by the name that this controls who can create buckets. There's 2 others that are very common, 2 actions, and that is get IAM policy and set IAM policy. They exist for every resource type, and I know I'm biased, but in my mind, these are the most important permissions, because these are the permissions that allow you to grant more permissions to other people or to yourself. So we'll get back to that in later slides, but remember, these are powerful. Of course, creating or updating a bucket could also be critical if you have something secret in that bucket. However, the set IAM policy, because it allows you to grant new policies, is order of magnitude more powerful. So let's take it from the beginning. An API is called. Say we want to call compute engine to get an instance. You call it. It will be translated on the back end to check against IAM to see, do you have this permission? In this specific case, we're going to check if you have the compute instance get permission on instance number 1. If you do, you will get the data you ask for. If you don't, you will get an access denied. So that is a simple API. Now let's make it more fun. Other APIs take a lot of different variables. In this case, we're going to one API call comes into compute engine, it's going to translate into 4 different permission checks on different resource types. And for this API call to be successful, you need to have all 4 permissions on those resource types, or this API call will fail. So now some of you in the audience think like, hey, permissions, I don't deal with permission. I've used IAM before. I only care about the roles. And to some degree, you're correct. Roles is the abstraction we use to grouping permissions together. So you can think about this as performing certain tasks or certain workflows that permissions belong together because it allows a user to accomplish a set of tasks or workflows. So we have actually 3 different types of roles in Cloud IAM. We have primitive roles, which we have there. They're very easy to use. We actually don't recommend that you use this in production. These are very, very powerful, and it makes it very easy to get started. Again, if you're a student or you're just tinkering, feel free to use this. If you're working for a large bank or something like that, please don't use this. Instead, you should use predefined roles. They are narrower. They group things normally bound per service. And there's several hundreds of these predefined roles that Google have defined that we think that, oh, these belong together, this accomplish certain tasks. There is a few patterns there that basically every service have an admin and a viewer of a predefined role. There's many specialized roles as well, but it could also be that your specific use case calls for something more specialized. We call that custom roles. Custom roles allow you to combine any permissions together and create anything you want and say, for me, for my use case, I have this workflow, and I need my users to have this set of permissions, because to me, they go together. Maybe not go together for all of you, but for your specific use case, they make sense. Custom roles, while they can be used for anything, there's 3 very common use cases. It's to combine role. You look at the predefined roles that we have worked, that different teams have worked hard to create, and say, oh, I like these 2 roles, and I'm always granting them at the same time. Let's combine them, right? And the other one is like, hey, I like this role, but it has this powerful permission I don't like. Let's remove it. Or you say, this role has everything I need, but this one permission, and you can add it. So these are the most common use cases. However, you can combine anything you want. So now we talked about the permissions and the roles, and now we need to bind these to users. We call these bindings, obvious name, right? And you can bind it to an individual user or to a group of users. That group can also be a group of a group of a group nested, and everyone in the whole chain of those groups are going to be granted, right? The third type is a service account, and we're going to come back to that at later slides. Services account is basically an identity of a service or a robot, and all of these bindings can be combined, so you in one policy have multiple bindings with multiple different roles for multiple different people. And that when you combine all of those, you have a policy. So for you that like JSON, this is my favorite example. So you can actually write this and use command line APIs. And in this specific example, we grant the compute instance admin role to 2 users, to a user that is Mike and a group that is the admins. We say, this is my powerful roles, and I'm very selective on who I grant this to. I have another role that is less powerful, compute viewer. I can grant them to everyone in my domain, or I can grant them to a specific service account. So we have now talked about our permissions and how we combine into roles, how we bind them to users, our members, and now we talk about a hierarchy. So all of these can be granted in hierarchy. And this is a core to how Google do identity and access management. You can grant these policies literally anywhere in your resource hierarchy. If you start and granting something in the org level, super high up in your hierarchy, it will be very powerful. The higher up, the more powerful, because the permissions is inherited down. So everyone in your org, every resource that is ever created would be affected by this policy. Versus if you do the other extreme, you put a policy on the individual resource. Now only that resource will be granted that specific role. That is also not the best practice, because odds are you might be successful one day and end up having millions and millions and millions of these resources, and now you have millions and millions of policies to manage. So the best practice is to think about how you in your organization work. What makes sense? And I'm going to come back in the best practice and do a couple of deep dives in exactly why we use the hierarchy and how we recommend reason about it. I told you I was going to come back to service accounts. So think about service account as the identity of one service. And that's the best practice, that this service account should take the identity of a specific service you have. This service account can manage and be the identity of multiple virtual machines. You can have multiple service accounts inside the same project, and these can be granted any other role, so they can act on other projects and on other resources. So in this example here, you see that this service account acts on buckets in other projects, and that's totally fine. And you can say one service account access one bucket, and my other service account access my other bucket. And this is where people sometimes get slightly confused, I have to admit, and that is that these service accounts, they are both an identity by themselves and a resource, which means that you, as a user, can grant access to the service account themselves, and the service account is an identity. So there's one powerful permission, especially that I'm going to come back to as it relates to service account, that is very, very powerful. So just save that for now. Now we're going into our second part, the best practices. So say that you're starting up and you just have your first data scientist join the company. You don't have that many resources, and you want to grant her 2 different roles for 2 different resources. And you might be inclined to say, like, oh, yes, let's put Alice in the binding for these 2 policies. That's not best practice. If you instead, from day one, create a group called data scientist in this example, and you add Alice to that group, once your usage in cloud grows, it might be that you add many, many more resources and many more policies. And then, as you are very successful, you hire another data scientist. Now, instead of finding all of the places where you have granted Alice permissions, you just add your new hire into that data scientist group, and you know that now Alice and the new hire will have the same permission to the same resources. This allows you to manage at scale. In the beginning, I talked about the super powerful set IAM policy permission. And as they are so powerful, because you can grant additional policies, additional permissions to other people, and to yourself. Right? Remember that. Like, this is very powerful. It doesn't just limit you to grant other people access. You can escalate your own privilege, which makes this very, very powerful. So think in this hierarchy, who do you grant this permission to, and how high in the hierarchy? Remember, the higher in the hierarchy, the more resource they can grant access to. The other one, as I mentioned, is the act as service account permission, which means that the user can act and do everything as the service account can do. So the best practice here is to grant this on the service account themselves and not up in the hierarchy, even though you will be very tempted because it's convenient at this point in time. Because later in time, odds are you're going to create more service accounts. And now, that grant is automatically granting those users to act as all of those new service accounts that didn't used to exist, but now might have access on sensitive data. So this is the one case where you really, really want to put your policy on the resource itself. In this case, the resource is an identity, which is the service account. And we have seen some of these. You know, it's very convenient. There's an API. It has a free field, say a description. You can put anything in there. Please don't. If you have secrets, treat them as secrets. Put them in a storage bucket and put the privileges and the permissions that is appropriate for that permission, for that super secret bucket that you have, and not try to code it in as metadata in other policies. And this leads us to leave a trace. Say that you just created your super secret bucket with all the company's secrets, and someone has access to it, and you don't know who. So by default, all changes, admin changes to the cloud is audit logged. So if you do a set IAM policy, it's going to be logged, and you can see who did that, who granted a permission, who changed the policy. That is logged. But we don't know by default that you have a super secret bucket and you care deeply about it. So in this IAM policy, you can also turn on audit logging. And you can log when someone changed, in this case, this bucket, or if someone accesses it, like who reads this bucket? Because remember, it's my super secret bucket. If you want to retain these logs for a longer period of time, you can export them to cloud storage or to BigQuery if you want to query them. There's also centralized logging systems such as Stackdriver that can trigger events and have things happen when certain logs come in. And I know I'm biased. I hope this is big enough for you to see. Every week, IAM publish all new permissions and roles. And regardless if you use the predefined roles or the custom roles, a best practice is to visit this page and see what has changed for two reasons. If you use the predefined roles, we will tell you that this coming week, we're going to add permission to a role that you might be using. And you're like, oh, that's good to know because effectively there's new permissions being added into my system. The other way is you use custom roles. And there's a new API or a new argument to an API that you really want to use. But your custom roles didn't have that permission because we just made it. So you have to manually read through this and say, I need to add this permission to my custom roles so that my developers or my robots or my service can take and call this new API or use these new arguments for this API. bring your organization structure to the cloud. And this is just practical. It's you setting up your company. You have thought, hopefully, deeply about who reports to whom and reporting chains, and if something breaks, who do you go to? If your cloud resource hierarchy doesn't match that, how do you now find the person responsible to grant you more privilege? Something is broken. Might be broken in your production system. And you need temporarily more access. Who do you ask? If this match how your company is set up, if that person is your manager, that's a great thing. I promised some deep dives into how we leverage the hierarchy. And this is the first out of 3 examples. So the setup is that we have developers and IT admins. And we have the IT admins that have a project, and in this project, they have the shared images. Their role and their work, actually, is to manage these images, make sure they're up to date, they are patched whenever there's a security incident, someone publish, whatever operating system you're using, a new image. So you want to grant the IT admins the instance admin role, so they can change and update all images under this project. Notice this is on the project itself, so as images comes and goes, you don't have to change your policies. It's an important detail here. And on the project, you also grant the developers image user roles, so that all your developers can use these images in their projects. And then the developers themselves in their projects will have the instance admin, and they can then use the images that the IT admins have created and manage for them. Let's take another example. We have the same setup. Developers, IT admins. In this case, however, it's different because we have different subnetworks. And some subnetworks are made for developers to play and experiment and develop. We have other where running your sensitive workload in production. So instead of granting the developers up on the project level, say, use any subject network you want, you will grant them the policy on the subnetwork itself that you allow for them to develop on. For the developer, no change. They will grant the same instance admin on their projects. And whatever time they create new projects, they can use this subnetwork too in this example. Let's make the hierarchy a little bit deeper. We have a finance team. First of all, we have a company that is larger. We start to have divisions. Someone in this division is responsible for managing your budgets. How much can we spend? You have sub-teams. The different teams can see how much they spend, but not how much the other teams spend. And they cannot change their own allowance. They cannot set their own budget. You want the finance manager to do that. So you will grant the finance manager for this division the billing account admin role as high up in the hierarchy as you can, in this example, in the division. And again, as high up as you can, you want to grant the billing account viewers to the teams that are affected. So team A and team B, you put those on what we call a folder level. This allows any project that team B creates in the folder to automatically have the correct policies. Instead of having to change and remember to go back for every project that team B creates in the future to add themselves the permission or the policy to see this. You put it one level up, and it's there. And now we're growing the company, right? We're even larger. And we see like, oh, I'm doing these workflows. And you will find that you have very common patterns that, in this example, you create project, you might create an app engine, you want to enable billing, you want to enable some APIs, you want to create service accounts, and you want to set some policies. And it's like, oh, that's a lot of work. And you might even want to create custom roles that you add to these policies, all programmatically. Of course, you can go out and write your own scripts and do exactly the things you want. Or you can use the deployment manager. It's a declarative tool that allows you to focus on what's important to you. What's the properties of the virtual machine you want to configure? You can say, I want my virtual machine to have this much memory. I want this type of CPU. And you actually no longer have to care about how this happens. You go to deployment manager and say, this is what I want. And you're setting up these flows. And then you're done. It's a fully hosted service. And it abstracts away that. It makes sense when you're having the same workflow, creating a lot of resources at scale. And now we have a story time. So Naveen from Credit Karma is coming up to tell us about how they leverage IAM and the policies.
Thanks, Patrik. Hello, everyone. My name is Naveen Godati, working for Credit Karma as a senior security engineer. So today, I'm here to share the Credit Karma story of implementing identity and access management in the Google Cloud Platform. So before we jump into the details, let me just give you a brief background on what we do at Credit Karma. So we actually offer a lot of financial services to our members, like credit scores, auto loans, personal loans, recommendations, etc. So our core mission at Credit Karma is to help our members make financial progress by utilizing all these services. We have about 80 million of users who subscribe to Credit Karma and using these services. So it is an absolute requirement for us to host these services on a platform that is much scalable, efficient, and secure. So when we started thinking of migrating to the Google Cloud Platform, we started off with some initial goals that will help secure our infrastructure in a better way. Like, we wanted to restrict the access to the GCP console so that we would allow only a specific set of one team or individuals accessing this GCP environment. We also wanted to enable this federated single sign-on process so that our employees can use their own enterprise credentials and doesn't need to use a different ID or anything. And at the same time, we wanted to enforce this multi-factor authentication checks and perform the authorization by implementing the GCP role-based access controls. And we would like to reduce the burden on our administrators without manually provisioning the identities in the GCP platform and just by automating it. And minimize the human activity in the GCP environment by leveraging the GCP organization model. So how do we do this? The first step of the process is authentication. We know that GCP is powered by the cloud identities that can be created via the G Suite. So what we did was we procured a G Suite, and we hosted all of our identities in there. So G Suite also supports the single sign-on capabilities that can be enabled via SAML. So we took advantage of that. Having this SSO enabled, we were able to delegate all of our authentication activities to our own enterprise IDP platform. And that also gave us the flexibility where you can enforce additional security restrictions like enforcing MFA and also making sure the users are coming from the approved private networks while accessing these GCP resources. Additionally, as a best security practice, we wanted to enforce the limits on the session length of the users. And G Suite has a flexibility for that. So if a user exceeds the particular configured limit, they will be forced to re-authenticate and identify themselves. So having these pieces in place, we were able to secure the path of accessing the GCP of our employees. Now, let's take a look at how this flow works. Employees on the Credit Karma side will be accessing the IDP portal, and they will be authenticating to this IDP portal with the credentials that are validated against the directory services, which is also hosted in our premises. Once the user is successfully authenticated to the portal, our platform is going to generate a SAML token and post it onto the G Suite. Now here, this G Suite, which is acting as a SAML service provider, verifies the authenticity of the token by verifying the certificate, signature, and identity in it. And if everything is well, then G Suite is then redirecting the user to the Google Cloud Platform by using the SAML real estate. So this way, we were able to secure the path of accessing the Google Cloud Platform, making sure the user is going through all the security checks that we enforced along the way. Now, you have the authenticated user on the GCP platform. And the next part is the authorization, right? How do we do this, right? So in GCP, when we are trying to authorize the users, first of all, we would like to enforce the concept of least privilege, and which is by using the predefined roles or the custom roles. But when do we use these predefined roles, or when do we use these custom roles? Let's take an example, right? If a developer is requesting an access to one of the GCP resources, like the storage bucket, as Patrik mentioned, we will be assigning them with predefined roles like a storage bucket owner or the writer or even the admin role, so that the developer can get all the permissions that he needs, where he can update objects inside the bucket or delete the objects inside the bucket. But these predefined roles at sometimes gives you an additional privileges of setting the IAM policies, which means where he can delegate the access to some other users as well. And we don't want it to do that, because now we wanted to enforce the concept of segregation of duties, because we have a separate team who is actually performing that access management activity. And this developer was supposed to only work on the bucket by updating the objects inside the bucket or deleting or creating the new buckets. So this is where we started creating the custom roles. And creating the custom roles is very easy in the GCP. You can just create it from an existing role by unchecking the permissions that you don't need, or even you can create a custom role by selecting each and every granular permission that you need. And once we have this exercise done of granularizing the existing roles or creating all the required custom roles, then we started off with creating the Google groups. And as a best practice, we always map our roles to the Google groups, so that we don't need to manage this access activity at the GCP IAM. We don't need to change these policies every time. And we can do that activity at the Google groups. And we always try to avoid assigning these GCP roles to the individuals in the GCP IAM platform. And then granting privileges only on as-needed basis. This is to make sure that when we are trying to elevate the privileges of a developer for a specific duration, we don't want to keep these privileges on a forever basis. We wanted to revoke them once the developer's job is done. And this is a concept where we implement this privilege bracketing. And the next thing is auditing and monitoring. We use the tools like the Forseti, which continuously keep track of all the policy changes happening on the GCP IAM, and also notify us with any violations happening there, so that we could go back in there and then fix that. This way, again, implementing these concepts and having the role-based access controls in place, we were able to authorize the users who are accessing the GCP resources. And finally, the GCP organizations. We use these GCP organizations to effectively manage our infrastructure resources and projects. Again, we followed the best practices recommended by Google while implementing these organizations. We started off with creating a parent org node at the top, which represents our enterprise. And then each and every department in our enterprise is represented by using the GCP folders. Once you get into the departments, as department owns multiple applications and the products, we created a separate project for each and every application that we hosted in there. And finally, each and every project is assigned with all its required GCP resources. So just to sum it up, we followed these best practices where we delegated our the authentication activities to our IDP platform. We use the predefined roles or the custom roles most of the time and avoid using the primitive roles. And we always map these roles to the Google groups. and then enforce the concept of segregation of duties. And all of these things together will help you achieve the least privilege in the GCP environment. So Patrik is going to share a few more interesting updates in the next slides. Thank you so much.
So I promised a sneak peek of something that we haven't announced yet. You're first to hear it in this room. IAM Conditions. And we have some of the developers built it right here. So shout out to them. So what is IAM Conditions? It's a new feature that allows you to use information from the client, such as what IP address was used, and say, oh, if you're coming from this IP address range, you can do more powerful things. You can say, like, if the resource has a specific pattern, like if it starts with a specific few characters, say dev or prod, they're different. And you can combine multiple of these attributes with Boolean expressions and combine it into very elaborate things. So we're going to dig into some of those examples. So say that you have a trusted device over your corporate network, and you can now grant a policy to the editor role that is powerful and say, I trust you, same user, but if you're working from your desk, you can edit and manage this resource. But the same machine, but you take it home. Maybe you work from home. It's still your trusted device that the company gave you. You now get a viewer role. You can only view this resource. And if you go into an internet cafe, you still log in. It's still you, same the correct credentials, and you will not get any access at all. Another one that people are asking for a lot is expiring policies. So you can create a policy that has a time bound. It starts at some point, and it ends at a different point. So I said that this is a Boolean expression. You can express this in common expression language. It's a relatively new language that Google have introduced. It optimized to make it easy to understand, to write and reason about your attributes. And we have also announced access policies, which is a different concept in cloud. But these access policies have something called access levels. These access levels can be combined with IAM conditions. So requests can be classified with different access levels. Again, depending on how safe you think this access is. And then you put those in your policies, in your bindings. So how would that look like? Let's go back to one of my earlier slides with you have a storage admin, a powerful role. And you have Mike and the admins again. But this time, I want to restrict it to only work from my corporate network. I will go and set up access levels that I define what that means. What does corporate network mean to me? And now, this will grant only this storage admin this access if they meet that requirement. So we have some key takeaways. We want to grant roles to groups, not to individual users. Use the hierarchy. Think about where in my hierarchy do I want to grant this permission? Is it a powerful one? Is it a weaker one? Use the correct role type and the correct role, for that matter. If you're doing a big production system, use the predefined role or your custom roles. Don't put any secrets in your metadata. Turn on audit logging for your sensitive workloads. Once you grow in scale, start thinking about how to automate. to minimize the human errors. And lastly, bring your organization structure to the cloud. And this means both in terms of the hierarchy. It means how you create roles. How do you name your roles? Name them things that make sense for you and your workloads. How do you work in your company? Do you have a role that you call data scientist? Maybe you create a role named data scientist. Maybe you have a group for data scientists. Suddenly, it makes sense, and it's much easier to manage.